Okay, here we've got a video on negative and zero exponents. By the end of this video, you should be able to simplify expressions such as these that involve negative exponents. And we'll also talk about a little bit about what it looks like with zero exponents. So before we know how to do this, let's cover the idea behind it. And basically, I'm just going to fill in this table and see if we can see a pattern. This isn't really a proof of how you do negative and zero exponents, but it is a pattern. And it's true, and I think it illustrates the idea pretty well. So if I just simplify each of these expressions, 2 to the fourth is 16, 2 to the third is 8, and then I've got 4, 2, and now I run into a 2 to the 0 exponent. Well, trust me when I say that this pattern is going to continue. So I see that, okay, it looks like we divide by 2 to get there, and we divide by 2 to get there, so on and so forth. So then I say, what's 2 divided by 2? And that's actually 1. And then once again, I go, what's 1 divided by 2? And that's going to give me 1/2. And then 1/2 divided by 2 is going to give you 1/4. So if this pattern continues, and so maybe the wheels are turning, you're starting to see, okay, maybe you figured out what to do with this. But basically, what you're saying is if I have a 2 to the negative 1 exponent, that's the same thing as 1 over 2. And if I have 2 to the negative 2 exponents, that's the thing as 1 over 2 squared. So 2 to the negative 3 would be the same thing as 1 over 8, or in other words, 1 over 2 cubed. And so the idea is that if you have a value raised to the negative exponent, that doesn't mean that this is going to be a negative answer. It means that it will be the reciprocal of that value. If it's in the numerator, like right now this is in the numerator, you're going to place it in the denominator. And the reverse is also true. If I have a negative exponent in my denominator, let's say I have 1 over 4 to the negative 2, then it's going to come to my numerator and become 4 squared, or in other words, 4 squared over 1. The other big idea is that 2 to the 0 is 1. And this will be true for anything. Anything to the 0th power is 1, okay? And we'll come back and we'll do an example just with a 0th power question, but really just got to flat out memorize that anything to the 0th power is 1. So, based on these ideas, let's look at the next page. Now, once again, if you want to do these problems, you need to watch my other 2 videos first. I've got basically problems that are going to involve all of our exponent properties, and so if you've only watched this video, you might not see where I'm getting some of these answers, but right here, I know if I have a fraction raised to an exponent, it's the same thing as, and I'll work down the page since I didn't leave myself much room. It's the same as raising both the numerator and the denominator to that exponent. Now, I have a negative exponent in my numerator, and as we just addressed previously, a negative exponent means that this is going to go to my denominator. And here, I have a negative exponent on my 8, so it's going to come to my numerator. So then I could simplify 8 squared and make it 64 over a squared, but that's as simple as that expression gets. Now, let's look at this next one. This next one is pretty similar, but the only difference is instead of raising the whole fraction to the negative 2nd power, we're only raising the numerator, okay? So I've kind of tried to divide and leave us some space here so we can differentiate, but here the a has a negative 2 power, so we know it's going to our denominator. But the 8 does not automatically come to the top. It doesn't just flip. It has a positive exponent, so it's already where it's supposed to be. Here the 8 had a negative 2 exponent, so it had to go to the numerator. But since this 8 already has a positive exponent, I'm going to leave it in the denominator. So that means I have this value, and there's really nothing left in my numerator except a 1. So this becomes 1 over 8a squared. And let's do this last example. And so maybe from the second example, you've kind of seen the pattern that if it has a positive exponent, it's going to stay where it's at, whether that's in the numerator or denominator. And if it has a negative exponent, it's basically going to go to the other one, wherever it's not, as far as numerator and denominator goes. So if we come here, I see the x to the negative 3rd, that's a negative exponent. So it's not going to stay in the numerator, it's going to come to the denominator. The y doesn't have an exponent, or if it doesn't mention it, its exponent's 1. And so it's going to stay in my numerator. Z to the negative 2, well, that's got a negative exponent, so it's going to come to my denominator. And the m it doesn't have a negative exponent, so it's going to stay in my denominator. The order that you write these terms in doesn't really matter. You know, I could have written the m first because the commutative property of multiplication says that when these three values are being multiplied, the order doesn't matter. So that simplified is this. And so that's really our two main ideas. What to do with the negative exponent. If I'm not to use mathematical terms, I'm just going to say flip it. And then when you've got a zero exponent, remember, we could work an example, but the example is, 3x squared. This is what I like to do with my classes. Z to the 11th over 2 to the 4th, x to the negative 57th. And I just raise the whole thing to the 0th power, and that's 1. Okay? Because anything to the 0th power is 1 except 0. So there's our two main ideas for this lesson. If you can do questions like these three, you should be good to go.